Satellites play a crucial role in modern technology, including communication, weather forecasting, navigation, and scientific research. Many satellites are placed in special orbits around Earth so they can operate efficiently. A geostationary orbit is actually a special type of geosynchronous orbit with specific conditions. Understanding the difference between geosynchronous and geostationary orbit is important to get an overview of both of these orbits. What is geosynchronous orbit? A geosynchronous orbit is a type of Earth orbit in which a satellite takes 24 hours to complete one revolution around the Earth, matching the rotation period of our planet. Because of this synchronization, the satellite returns to the same position in the sky at the same time each day. However, it may still appear to move slightly north or south relative to a fixed point on Earth. These orbits are commonly used for communication, weather, and observation satellites. What is geostationary orbit? A geostationary orbit is a special type of geosynchronous orbit in which a satellite moves around the Earth with the same rotational speed as the planet. The satellite orbits directly above the Earth's equator at an altitude of about 35,786 kilometers and completes one revolution in 24 hours. Because of these conditions, the satellite appears completely stationary over one fixed point on Earth. This orbit is widely used for communication, television broadcasting, and weather satellites. Difference between geosynchronous and geostationary orbit. Both geosynchronous orbit and geostationary orbit are important satellite orbits used for communication, weather monitoring, and scientific observation. The difference between geosynchronous and geostationary orbit has been highlighted below. Difference between geosynchronous and geostationary orbit. Basis of difference. Geosynchronous orbit. Geostationary orbit. Definition. An orbit in which a satellite takes the same time as Earth, 24 hours, to complete one revolution. A special type of geosynchronous orbit where the satellite remains fixed over one point on Earth. Relation between them. General category of orbit. Subset of geosynchronous orbit. Orbital period. 24 hours, same as Earth's rotation. 24 hours. Satellite motion from Earth. Appears to move in the sky. Appears completely stationary. Orbit shape. Can be circular or elliptical. Always circular. Orbital inclination. Can have any inclination relative to the equator. Must have zero inclination, 0 degrees. Location of orbit. May orbit above different latitudes. Must orbit directly above the equator. Ground track. Forms a figure-8 pattern, anal lemma, when viewed from Earth. Appears as a single fixed point. Satellite position. Changes position over Earth during the day. Remains above the same longitude. Altitude. Usually around 35,786 kilometers but may vary slightly. About 35,786 kilometers above the equator. Coverage area. Covers different regions during orbit. Continuous coverage of the same region. Ground antenna requirement. Ground stations must track satellite movement. Ground antennas remain fixed. Communication stability. Slight signal variation due to satellite movement. Stable communication because satellite is fixed. Applications. Scientific observation, communication satellites. Television broadcasting, weather satellites, telecommunications. Examples. Some research and communication satellites. Weather and communication satellites like INSAT satellites. Visibility from Earth. Appears to move north, south during the day. Always visible at the same position in the sky. Polar coverage. Can observe wider latitudes depending on inclination. Poor coverage of polar regions. Complexity of operation. Requires tracking systems for antennas. Easier operation due to fixed satellite position.